Hello everyone, welcome back to Amin Maths Club. Today we are going to solve a challenging Math Olympiad problem, and I hope it will boost your problem solving skills. So our problem is x to the power 6 plus 1 over x to the power 6 is equal to 970. So here we have to find the value of x minus 1 over x, all possible value of x minus 1 over x. And remember that here x is the element of real number. So starting our solution, first of all here x to the power 6 can be written as, if we just write x squared whole cubed, which is equal to 2 times 3 is 6. Similarly we have 1 over x squared whole cubed, that is equal to 970. Now here we have, here this one is also 1 is equal to 1 cubed, so we are going to write x squared whole cubed and plus 1 over x squared whole cubed, that is equal to 970. Now according to algebraic identity, here a cubed plus b cubed, it is equal to, that is we know that if we have a cubed plus b cubed, then it is equal to a plus b times a squared minus a times b plus b squared. So applying this identity here, then it will be, that is a plus b, which is 1 over x squared. So a plus b times, here we have a squared, so a is x squared, then it will be x squared whole squared minus a, which is x squared, times b, which is 1 over x squared, and plus 1 over x squared whole squared, that is equal to 970. Now our next step will be x squared plus 1 over x squared. Here we see that this x squared whole squared, that is, if we just write x squared whole squared, and here this x squared is cancelled out with x squared, we get minus 1. So if we just write this step here like x squared whole squared and minus 2, here we just put plus 2 times x squared times 1 over x squared, and similarly if we just add this one and subtracting this term here, minus 2 times x squared times 1 over x squared, so cancelling this we get that 0, so there is no difference. We are going to add this term and minus 2x squared 1 over x squared, subtracting this one, so we have here plus 1 over x squared whole squared, that is equal to 970. But here we have also, if we just cancel x squared with x squared, we get minus 1, so here we are going to write that is minus 1 as well, minus 1 as well. So here x squared plus 1 over x squared times, here we see that it is our a squared plus 2 times a times b, and it is our, that is 1 over x squared is our b squared. So if we just rearrange this term here, that is x squared whole squared, and now plus 1 over x squared whole squared plus 2 times x squared times 1 over x squared. So if we just write inside bracket, here we get minus 2 times x squared times 1 over x squared, and here we have minus 1, that is equal to 970. Now our next step here, we are going to write that x squared plus 1 over x squared, x squared plus 1 over x squared times, it is our a squared plus b squared plus 2 times a times b, so we have x squared plus 1 over x squared whole squared. That is, this x squared is cancelled, we get minus 2, and minus 1 we have minus 3 is equal to 970. Now x squared plus 1 over x squared is same as x squared plus 1 over x squared, so we are going to just suppose that let this x squared plus 1 over x squared is equal to t. Now if we substitute this value, so here we get this step will be that x squared plus 1 over x squared is equal to t. So t times, here we have t squared and minus 3 is equal to 970. Now t times t squared is t cubed minus 3t. Shifting this one, we get minus 970 is equal to 0. Now t cubed minus 3 times t and minus this 970 can also be written as, if we just subtract 30 from 1000, so we get 970. 1000 minus 30 is equal to this one, that is equal to 0. Now if we apply this negative sign into parentheses, then we get, here we have t cubed minus 3 times t minus, here we have 1000, minus time minus is plus 30 is equal to 0. Now our next step will be, so t cubed, if we write with this 1000 here minus 1000 and this minus 3t plus 30, that is equal to 0. Now this t cubed 1000 can be written as minus 10 cubed here. So if we make pair, it is our first pair, and here we see that 3 is common, so taking minus 3 is common. Then inside bracket we have t minus time plus is minus 30 divided by 3, we get 10 is equal to 0. Here we are going to just use algebraic identity, which is a cubed minus b cubed, and as we know that a cubed minus b cubed is equal to a minus b times a squared plus a times b plus b squared. So applying this rule here, then it will be t minus 10 times t squared plus t times 10, which is 10t, and plus 10 squared. Here we have minus 3 times t minus 10 is equal to 0. Now this t minus 10 and t minus 10 is a common term, so we just write t minus 10 is a common factor. Then inside bracket we have t squared plus 10 times t plus 10 squared, which is equal to 100, and here we get only minus 3, that is equal to 0. Now this t minus 10 is equal to 0 using 0 property here. So t squared plus 10t plus 100 minus 3 will be plus 97 is equal to 0. Now we have two equations. So from first equation, here t is equal to minus 10 will be plus 10, so we get value of t. Here from this equation, it is a quadratic equation, and first of all we are going to find the determinant. So here value of a is 1, b is 10, and c is 97. So determinant is equal to b squared minus 4ac. We are going to check the determinant is less than 0 or greater than 0. So here we have determinant is equal to b squared, which is 10 squared, minus 4 times a is 1, c is 97. Determinant is equal to 100 minus, here we have 97 times 4, we get 388. So determinant is equal to minus 388 that plus 100, so we get minus 288. So minus 288 is actually less than 0. So if it is less than 0, then we have a complex solution and no real solution here. Now if there is no real solution, as we have given in problem that x should be the element of real number, so we are going to reject this value because it is a complex solution. Now taking this one, t is equal to 10, so as we have supposed that, but we know that here x squared plus 1 over x squared is actually equal to t. According to this position, we have x squared plus 1 over x squared is equal to t. So applying here, we get x squared plus 1 over x squared is equal to t. Similarly, x squared plus 1 over x squared, t is equal to 10. So putting the value of t here we have x squared plus 1 over x squared. So if we simply just subtract minus 2 here on our left hand side, and similarly subtracting 2 here on our right hand side, so here we can make a perfect square. So x whole squared is equal to x squared, and minus 2 times x times 1 over x. Here we have plus 1 over x whole squared, that is equal to 10 minus 2 is equal to 8. Now it is our a squared, as we know that by algebraic identity a squared minus 2 times a times b plus b squared, that is equal to here we have a squared plus b squared, uh, it will be a minus b whole squared. So it is equal to a minus b whole squared. Now applying this identity here, then we get here we have x squared minus 2 times x times 1 over x and plus 1 over x whole squared. So it is equal to x minus 1 over x whole squared, which is equal to 8. Now we have to find the value of x minus 1 over x. So this squared can be removed here, that is x minus 1 over x whole squared, taking square root on both hand side, so square root of 8. Now this squared is cancelled out with square root, we get x minus 1 over x is equal to plus minus, here square root of 8 can be written as 2 times 2 times 2. So we have x minus 1 over x is equal to plus minus, here we have we just take to outside square root and 2 times square root of 2. So our final value of x minus 1 over x is plus minus 2 times square root of 2. So it is our final result. Hence we just find out the value of x minus 1 over x here. So that is our answer. Now we are going to just check our entire solution here step by step. So I hope you have really enjoyed this video. So if you found this helpful, then give it a thumbs up, share it with someone preparing for Math Olympiad, that competitive exams, and don't forget to subscribe for more interesting contents. Thanks for watching. Have a nice day. Goodbye.